Okay, so this is the Chapter 16 review. Number 1 says, which of the following statements is the correct interpretation of the value 9.97? If I'm looking at that, hopefully you recognize that 9.97 is the slope. I do recognize that there is a kind of a typo. If you look up there, it says time, and then it says 5, and then 37.21. That 5 is supposed to be an equal sign, and that 1 is supposed to be a plus sign, right? So that if that were an actual regression output, it would show the equation. Now we know if we were to give the regression equation, we would say predicted time, right? Predicted time equals 37.2 plus 9.97 times what number of components. Okay, so I guess it's predicted time of the service call. So number 1, which of the following is the correct interpretation? On average, the service call time goes up 9.97 minutes for each additional component needing repair. That's B for number 1. Okay, that's an interpretation of the slope. Now that's really old. We went over that a long time ago, but that works. Okay, which of the following statements is the correct interpretation for 89.7? 89.7 is R squared. So approximately 89.7% of the observed variation in service call time, so that's in Y, can be explained or attributed to, either way you say it's fine, the linear relationship between service call time and number of components needing repair. Sorry. So that's D. Okay. So make sure you know how to interpret the slope. Make sure you know how to interpret R squared. The value of S sub E is 18.75. Which of the following is an appropriate interpretation of this? That one's also D. The magnitude of a typical difference between observed time and the predicted time in the linear model is approximately 18.75. Notice how with standard deviation it says the word typical. That's probably a good answer. So 3 is D as well. Okay. It says the value of S sub E is 18.75 if the assumptions for a simple linear regression model are satisfied. Which of the following is correct? This is C. It would be unlikely that the prediction based on the regression line will differ from the actual value by more than 2 times 18.75, or 37.5 minutes. That's using, okay, one, it's using the T distribution to get, you know, a 95% test statistic, or 95% T critical value, which is about 2.1. They just rounded that off to 2. And then it's doing essentially your confidence interval formula, which is B plus or minus your T critical times S sub B, right? Why are they giving you S sub E there? Be unlikely that the prediction... Oh, no, I'm sorry. So that's S sub E, so I was interpreting that wrong. Not S sub B. This is our standardized residual. This is how we determine whether or not it's an outlier, 2 standard deviations away from the mean. Sorry about that. So that's why it's C. Okay. Number 5, which of the following is... So here's the right one for number 5. Which of the following is a 95% confidence interval for a 1 unit? So 95% confidence interval for B. So this is where it's B plus or minus your T critical times S sub B. The B was 9.97. The T critical here is 2.1. Now don't use T from the Minitab output. That T is if you were carrying out a hypothesis test, that would be your test statistic. Your test statistic and your T critical value are 2 very, very different things. No, the one that's on the table is a linear regression T test. okay? But think about the difference between the two, all right? So let me finish writing this formula out. 0.72-ish, right? So let's talk about the difference between a test. Is that the fire alarm? Oh, okay. Oh, yeah, my phone's buzzing. No vehicle description. That seems like a real good thing. I get an Amber Alert with no vehicle description. Sorry for everybody listening to that. All right, so this is D. All right, so let's talk about the difference between the two. Okay, if I need to, and I'll go ahead and put this distribution up here for you to see. Somebody's phone's late. Somebody's got like a cricket phone or something. All right. All right. So here's T critical values that we use. So anywhere within here, we would use these for a 95% confidence interval based on degrees of freedom, right? Okay. This is how we pick a critical value. With a test statistic, though, for a linear regression t-test, our test statistic t is calculated as b minus our hypothesized value of beta. What is our hypothesized value of beta always? 0, right? Over S sub b, right? Well, S sub b is given in the output, so this is way different than looking at the table. This is saying if beta is in fact 0, how many standard deviations away from the mean is our data? So in this one, for this one, it says T is 13.81. This is 13.81 standard deviations above the mean. That's why the p-value is 0. Okay? 9.96 is a pretty darn big standard deviation to have, or a pretty darn big B to have a standard deviation of 0.72. So that's a big difference between a confidence interval and a hypothesis test. So be careful. Make sure you know the difference. All right. Number 6, if the basic assumptions of the simple linear regression model are appropriate, what conclusion should be reached regarding the model utility if a significance level of 0.05? When they say model utility, they're wondering how accurate, or is this a good model for predicting? Not how accurate, but is this a good model for predicting? So here we're saying there's definitely convincing evidence. Our p-value is 0, right? So there's definitely convincing evidence that the model is useful in predicting, or that there is a linear relationship between, number of components needing repair and service call time. So number 6 is C. If there is a positive linear relationship between two variables x and y, which of the following must be true of beta, the slope of the regression line? If there's a positive linear relationship, then beta should be positive, which I think is B. Okay? That one should have been really easy. All right, number 8. Number 8 gives us a bunch of different pictures here. It gives us standardized residuals, okay? It says the plots are shown, or it says the plots are residual plots resulted from fitting the linear regression. Which of the plots indicates that the linear relationship between two variables used to fit the line may not be linear? Hopefully you can see that there's like a V or a U-shaped pattern in the first one. Everybody see that? So that one definitely doesn't work. If I look at the second one, there doesn't seem to be any particular pattern. And in the third one, it seems to the standard deviation seems to increase as it goes through, which would affect our ability to do a linear regression t-test, but it's not saying that it's not linear. It still looks pretty random. So 8 is A. When they say there's a constant standard deviation throughout, and you plot your residuals, and they kind of look like this, where they kind of like form a cone almost. Okay? Something like that. This doesn't look like there's a constant standard deviation throughout, does there? No, it seems to be increasing as the values of x are increasing. So this would not meet that condition for inference. All right? Number 9, which of the following label points would have the largest residual when a linear model is fit to the data? The largest residual would be point C. And that's kind of confusing to some people. And let me show you what I mean. I've written in this book before, so I have to erase it real quick before I show you guys. Okay, so C is definitely far away in the y direction, and D is far away in the x direction, right? All right, so let's take a look at this. Okay? Whoop. Just moved my book. All right. If I was to fit a line to this, my line is actually going to be pulled by this influential observation. Now, the outlier is going to pull it somewhat too, but the line's probably going to look something like this. Okay? This D pulls this part of the line towards it. Influential observations, what they do is, when you look at an influential observation, it takes that regression line and it pulls it towards it. Okay? Because we're looking at deviations in x. So when you're looking at the calculation of the regression equation, that influential observation will pull the line towards it. Okay? So the largest residual is the one farthest away in the y direction. That's going to be C. Okay? That's going to be my largest error. All right? So that's why number 9 is C. Okay? Yes?
Why is the line like that way instead of coming down?
Oh, yeah, you're probably right. It probably is more downward.
Okay.
Yeah, that's a good question. Because I didn't sleep enough. The line should be coming, but instead of, yeah. So instead of it going kind of this way, right? This is actually going to pull it towards it. So it's maybe going to be more like this. Because D's going to, that should make a little bit more sense. D's going to pull it towards it. Now that still puts C probably even farther away in that direction. Okay? All right, so number 9 is in fact C. Number 10, which of the label points is a potentially influential observation? I think we just talked about that. So 9 is C, 10 is D, right? Number 11, if there is evidence of a linear relationship between x and y, what decision would be made in that hypothesis test? Well, we would reject the null hypothesis, and there would be enough evidence to conclude that there is a linear relationship. So that'd be B. Number 12. Okay, so 12 and 13 both use this massive Minitab. I said Minitab. Massive Minitab output. Okay, so let's look at that output real quick. Okay, so notice that there are some things in some different places than we're used to. All right, R squared is up here, which is kind of different than we're used to. Here's S, which is the standard deviation of the residuals. Okay, and then here is our linear regression equation way up top here. They have the equals and the minus, yeah. Okay. Number of observations, mean of the response, that's the mean of the y's. So like if I had all the y's, what's the mean? What's y bar, essentially? So number of observations, here's our degrees of freedom. this is our sum of squares. We don't really need this information. If you wanted to calculate S sub B or S sub E, this stuff is helpful, but we don't need that. Here's your y-intercept, your slope, your standard deviation of your slope, and your t, your test statistic, and p-value associated with that, okay? Again, this line right here is useless to us, this standard error of A, t of A, and the probability here, okay? So it says, for this data set, the model utility test is based on how many degrees of freedom. I can find that here, or I can do n minus 2. So either way, it's 16, which for number 12 is B. So I can go back. Number 12 is B. Number 13, it says, which is the p-value associated with test. We already looked at that. That was 0.0007, right? So that is B as well. (14). This is the one that talks about conditions for inference. Remember, I told you, I might not make you do the conditions on the test, but I might show you something like this. Okay. Now the answer to number 14 is B, but let me explain why, and let me explain what word I believe should be in here. And we've already seen that your book has some little typos, but I still think that's the best answer. Okay, so the distribution of E, the residuals, is normally distributed. That's something that is a condition, right? The standard deviation of the errors depends on a particular value of X. That was not a condition. The mean value of the errors is 0. That was a condition, right? Evenly scattered around 0. Random deviations associated with different are independent of one another. That was one of our conditions. And the last one was the standard deviation of E is the same, or we said approximately the same. I think that word approximately should be in here, and I think that this should say approximately normal, but just because it's saying normal and this one is definitely not a condition, right? The standard deviation of E depends upon a particular value of X. So while I think A and E both should have approximately in them, they're not, they're not incorrect, I don't think. All right, so number 14 was B. 15, the residual plot. Now, this residual plot's just like the one I just talked about, right? Where it kind of fans out. So for number 15, it says, which of the following is a reasonable conclusion based on the residual plot? If I'm looking at this, it definitely looks like there's evidence that the residuals do not have the same variance. And remember, variance is just the standard deviation squared for all of the X values. So 15 is in fact E. All right.